What's up, you guys? Okay, so this is my third or fourth, maybe, attempt at recording these notes. Fingers crossed it goes well this time. Okay, so for our test review, the test that is going to happen on Thursday and Friday of this week, the test is on 12/17 and 12/18 for second period. We're going to talk about proportional relationship equations. Proportional relationship equations. Okay, now there are three ways that you can get the three ways that we've talked about to figure out the equation of a proportional relationship. And the first way is by using a table. A table. We should be very familiar with these things. A table has x and y values on either side. Let's put in some values here. For x, let's use 3, 6, 9, and 12. And for y, for the corresponding y values, let's go with 1, 2, 3, and 4. So for x and y, we've got 3, 1, 6, 2, 9, 3, and 12. Oops, I said 12, 4, and I wrote 12, 1. 12, 4. Okay. Here's our table of x and y values. Now, when we're writing proportional relationships, the master equation that we're going to be using is the equation k equals, no, lies. The master equation is y equals kx. And what we're finding when we're writing these equations is what the value of k is going to be. The only thing we're going to change is k, and we're going to substitute a number for it. We're going to replace k with a number. And the way that we find out what k is we do k is equal to y divided by x. And we'll have numbers for x and y that we're just going to substitute for this fraction here to find out what the actual number is going to be. Okay, so we can pick any of these pairs of numbers here, okay, because we have x and y values for each. We've got 3, 1, 6, 2, 9, 3, and 12, 4. So let's choose this one at random. And for this one, our x value is equal to 9, and our y value is equal to 3. So when we find k, because that's what we're looking for k. K is going to be equal to y divided by x. And if we substitute in these values for y and x, for y, we're going to replace it with 3. And for x, we're going to replace it with 9. We get 3 divided by 9. And when we do 3 divided by 9, that's going to reduce and simplify to 1/3. So our k value here is equal to 1/3. Okay, now we found out what k was. Now we have to remember the master equation here. When we're finding an equation, we're putting it in this format, y equals kx. We figured out what k was. Now all we have to do is put it in the equation. We've got y is equal to k, but instead of k, we're going to put 1/3, because that's what we found out k to be, is 1/3 times x. Y is equal to 1/3 times x. Now this is true because we can take any value for x, multiply it by 1/3 and get the values for y. So we can take whatever the value for x is, multiply it by 1/3 to get to y. Okay, so that is how we find the value of, an equation using a table. Okay? Now the next way we can find an equation is by using a graph. Okay, so let's make a graph here. Let's draw some lines. Okay, so let's draw our graph. We've got 0, 0. Oh, first we can't forget to label, this is the x-axis and this is the y-axis. Across the bottom, I think I'm gonna go every other dot, and I'm gonna label them by ones. So 1, 2, 3, 4, 5, 6, 7, 8. That should be plenty. And then on the y-axis, I'm going to draw a little line on every other dot, but I'm gonna label them by 2. So 2, 4, 6, 8, 10, 12, 14, 16. That should be plenty there also. And then in a problem, you'll most likely be presented with a graph that already has a line and points on it. So I'm just gonna add some points here. Let's do 1. So the first point is going to be at 1, 4. The next one is going to be over 2 and then up 8. Then I'm going to go 3 and 12. And then 4 and 16. And we'll pause there, and I'm gonna get rid of my extra little tails. And then finally I'm going to draw a line, and because we're talking about proportional relationships, there is a point that goes through the origin. I'm gonna draw a line that goes through all of these as best as I can. Okay. Now let's also label these points. So the first one is 0, 0. Next, I've got 1, 4, then 2, 8, 3, 12, and 4, 16. All right, take your time, don't rush this step here. We want to be sure that we know exactly what point is where. Okay, so now when we're writing an equation, you'll see a question that looks something like this, like write an equation that represents the relationship shown on the graph. Okay, so that'll be your question most likely. Okay, now just because this is asking that question, we know that if we're going to write an equation, the equation has to be in the form of y equals kx. And anytime we have this equation here, we know that k is equal to y divided by x, and we can figure out what k is in order to put it into the equation because we have x and y points. Okay? Now, I'm just going to pick one at random. I'm going to pick the point I'm just gonna pick one at random. I'm gonna pick the point. How about, I'm gonna pick 3 and 12 here. Okay, so now here's where I think a lot of people get kind of mixed up, okay? K is equal to y divided by x. And in our heads, we think, okay, y, x, blah, blah, this divided by that. But that's not the case, okay? Because these points are written as x, comma, y. And you know what? I'm going to write that so that it stays. These points are written as x, comma, y. So we have to take the y and divide it by the x. The y, the second number here, the y goes on top and the x goes on the bottom. Okay? So when we do this, if we were going to do this for this value, our point here is 312. Our point there is 312. Our x value is 3. Our y value is 12. We know that k is equal to y divided by x. And if we substitute the x and the y for our values here, the numbers that we actually have, we have 12 divided by 3. And when we simplify that, and when we do that division, 12 divided by 3, we get 4. So our k is equal to 4. Now all we have to do is take this k value and replace it in this equation. We put it back in this y equals kx equation. And when we do that, when we put it back into, let me get this out of the way a little bit. When we put it back into y equals kx, it turns into y equals 4x. Y equals 4x. And that means for whatever point we have on our x-axis, we can find out without having to draw a line and making sure that it's perfect, whatever that point up there is going to be, we can just find out by plugging that into the equation. So if I wanted to know what the point at 6 would be on the line, instead of like trying to draw and figure it out and figure out what it is over there, who knows what that is, I can simply put 6. If I have x is equal to 6, what is y equal to? I can put that into this equation. Y is equal to 4 times 6. And what I would get is, well, what is 4 times 6? That is 24. That is way far above my graph here. This will basically only go to 18, 20, 24 is way up there. Okay, now the last example, the last way that this might ask you to make a equation, the last way that we're going to work on writing equations is from a word problem. So the third way, let's stick with our color scheme here. The third way is from a word problem. Oh my God, my handwriting. Word problem. So let's say we have this example that Mia bought 8 t-shirts. Mia bought 8 t-shirts for $56. You might see something that says, write an equation that relates the cost to the number of t-shirts. How much would it cost? So before I even write that down, So this is asking one thing. This is asking you to write an equation that relates the cost to the number of t-shirts. And then it might also say, how much would it cost to purchase 10 t-shirts? So, and this is the second thing that it's asking. It's asking how much it would cost to purchase 10 t-shirts. So there's two things that we need to figure out. And the first thing is we're going to write an equation that relates the cost to the number of t-shirts. Okay, so this is the cost and this is the number of t-shirts. But that's just for 8 t-shirts. That's the cost for 8 t-shirts. But we want to relate the cost for however many t-shirts we want to buy. And the way we do that is by using this equation. Oh my God, y equals kx. Okay, we're gonna figure out what k is in this equation. All right, now what is x and what is y? How do we know that? Well, in the equation, it says the cost first, then 2, then the number of t-shirts. So it's the order that it's in matters. It says cost to the number of t-shirts. Or, so we could write it like this with the colon here, cost to t-shirts. Or we can write it as cost over t-shirts. Okay, and this makes sense because this is like saying the cost per shirt. All right. The way that we figure that out is we take the values that we have and we divide. We divide the cost by the number of shirts. So we're going to do 56 divided by 8. Now I'm going to make sure that I label this. I labeled the top part with dollars here. We've got the dollars there. And the bottom part is t-shirts. So now let's figure out the value of that ratio. The numbers, what the number is when we divide 56 divided by 8. Well, I know that 56 divided by 8 is 7. But what happens to these units? Well, they're going to stay where they are. So $7 per t-shirt. Now that looks a little weird. So when we're talking about money, we would write it like this. $7 per shirt. Okay? So this is the unit rate. This is how much money per one t-shirt. All right? That is the same as what K is. K is another word, or unit rate is another word to describe what K is. I'll talk about that more in just a second, but let's put this back into our equation. Okay, if we replaced this with K, then our equation would look like this. It would look like y equals 7x. Now, sometimes these questions are going to ask you to use letters instead of x and y. So like C to represent the cost and T to represent t-shirts. So when we do that, we have to know which one is going to be X and which one is going to be Y. Well, if I look back over here, I did the dollars divided by shirts. And I always do Y divided by X, right? It's always going to be, K is always, I didn't even write that down. K is always Y divided by X. You know what, let me write it here. K is equal to Y divided by X. And our Y was $56 and our X was 8 t-shirts. So if X is t-shirts and Y is dollars, then the cost is going to go where the Y is and the t-shirts is going to go where the X is. So we might have to write an equation with different variables where the cost is equal to 7 times the number of t-shirts, or T, the number of t-shirts. Okay, so that's for the first question there. That's a lot for the first question. I kind of over-explained it a little bit. Okay, but the point again is to use what we have to find k. And then to replace that, once we found k, we put it back in the equation, back into this equation. Okay, now the second question is asking, how much would it cost to purchase 10 t-shirts? Well, I know that I want 10 t-shirts. So t-shirts is gonna be 10. I want 10 t-shirts. Now I'm just gonna put that right into this equation. C is equal to 7t. And when I do that, the cost is equal to 7 times 10. And I know that 7 times 10 is 70. So the cost for 10 t-shirts, I can't spell t-shirts, is $70. Okay, the last thing that I want to tell you guys is about this letter K. Okay? This letter K here that we see a lot, like I've been saying, if you don't remember anything else, remember the equation K is equal to y divided by x. Okay? You will see words and problems that say unit rate, and unit rate is saying like the amount of something per one of something else. The amount of something per one of something else. When it says find the unit rate, it's saying find K. So when it says find the unit rate, it's saying find K. You will also see the word, or this is also the constant of proportionality. The variable K, this variable K, is the constant of proportionality. So when you see the word constant in a problem, you will see the word constant in a problem. It's asking you to find K. So K, which is y divided by x, is another name for unit rate and constant.